Very well, friends. In this video, a review of trigonometry. Trigonometry is a big deal. It is all over high school mathematics. You've got to know trigonometry. It is helpful to know how trigonometry works with right triangles, although I imagine that you have studied this before. If I have a right triangle and I'm considering angle CAB, then we traditionally define the sine of angle A as the length of the so-called opposite side to the length of the hypotenuse. Now, the sine of A, that ratio will hold constant because no matter what size triangle I'm working with, all of these triangles, these four right triangles that share this common angle, and we know they're all similar because this angle is in common to all four triangles, and there are right angles. Because the corresponding sides of similar triangles are in proportion, this side to that one is going to be the same as this side to that one, is going to be the same as this side to that one, is going to be the same as this side to that one. So the sine ratio holds regardless of the size of the triangle because of similar triangles, because they are similar right triangles. So sine is defined as the length of the so-called opposite side to the so-called hypotenuse. In this case, that's the opposite side to the hypotenuse. Cosine is defined in terms of the adjacent side and the hypotenuse. The adjacent side is AB, and tangent is the ratio of the so-called opposite side to the so-called adjacent side, opposite to adjacent. Which means that if I have a right triangle, and this is a 32-degree angle, and this length here is 10, and I want to find that, then I think to myself, from the 32-degree angle, this is the opposite side. This is the side that touches up against that 32, that's adjacent. This is the hypotenuse. It's the longest side of the triangle. It may not be opposite or adjacent. And so what have I got? I've got opposite and hypotenuse. That's a sine problem. Can't write sine without writing an angle. The angle in this case is 32 degrees. Opposite divided by hypotenuse. And so quick cross multiplication swap. X is 10 divided by the sine of 32 degrees. And your calculator will tell you what that is. That's approximately 18.9 to 3 significant figures. Now we know that that's going to be the longest side of the triangle because it is the hypotenuse, and sure enough, it is the longest side of the triangle. Similarly, if we had a right triangle and we knew that this length was 7 and this length was 12 and we wanted that angle, we would again think to ourselves, from the x degree angle, this is the so-called opposite side, this is the adjacent side that slides right up along against it, and you've got the hypotenuse, the longest side of the triangle. So if I've got opposite and adjacent, that's a tangent problem. Can't write a trig function without an angle, so that's tangent of x degrees, and opposite over adjacent. So now what I need is I need the angle whose tangent is 7/12, and your calculator will tell you exactly what that is. And so you ask your calculator, what that is, and you get 30.3 degrees. 30.3 degrees. Okay? Things you should know how to do. You should know that in triangle ABC, if AB is 9 and BC is 6, you should be able to find the measure of angle A. And similarly, right angle at C, right angle at C. If AC is 25 and BC is 11, this figure is totally not drawn to scale. I want to know what angle A is. Figure totally not drawn to scale. So you should know how right triangle trig works. You should know that trigonometry applies in triangles that are not right triangles. So given any triangle where the side lengths, little a is the length of the side opposite angle A, little b is the length of the side opposite angle B, little c is the length of the side opposite angle C, you should know that a divided by the sine of angle A is equal to b divided by the sine of angle B is equal to c divided by the sine of angle C. This is called the sine rule, or the law of sines. And it works in all triangles, whether they be right triangles or not. It works in all triangles. So, if I have a triangle, and in that triangle, it's, I don't know, A, B, C maybe, and A is maybe 10, and B is maybe 65 degrees, and A is maybe 45 degrees, and I want to find little b. So the sine rule says any side divided by the sine of the angle opposite it is equal to any other side divided by the sine of the angle opposite it. And so I can find angle B just by saying that's 10 times the sine of 65 degrees divided by the sine of 45 degrees, and your calculator can figure out what that is, and you get approximately 12.8 to 3 significant figures. Now, does that make sense in the context of the problem? Well, 65 degrees is bigger than 45 degrees, so the opposite side here has to be bigger than the side opposite there, and it is, so our answer is reasonable. Now, not only does the sine rule help us find sides, the sine rule can help us find angles. So I take some triangle, maybe since we used A, B, and C already, we'll use D, E, and F, and maybe D is 16, and maybe E is 13, and maybe angle D is 45 degrees, and we want to find the measure of angle E. And so again, any side divided by the sine of its opposite angle and so what do we do from here? I can find the sine of E. The sine of E is 13 times the sine of 45 degrees divided by 16, which your calculator will tell you is 0.5745 approximately. So how do I find angle E? Angle E is the angle whose sine is that. And that's not hard to get. 35.1 degrees to 3 significant figures. And again, that makes sense. The 16 is bigger than the 13, so the opposite angle here has to be greater than the opposite angle there. We should note There are two angles whose sine is 0.5745. One of them is in quadrant 1. The other one is in quadrant 2. It's about 145 degrees. But I can't have an angle that's 145 degrees if I already have 45 degrees in the triangle. There are some times when this other angle will be legitimate. So you've got to find it and discount it. You have to find it and you have to discount it. It's called the ambiguous case of the sine rule, and your trig teacher will probably tell you more about that. Hey, not only is sine useful, cosine is useful. I mean, I didn't think there was any serious doubt about that. But there is such a thing as the cosine rule. And the cosine rule says that if I want to know what c squared is, well, that's a squared plus b squared, and you're thinking that's Pythagorean theorem, except that there's this extra minus 2ab cosine c hanging out. So when I focus my problem on this angle, and I know information about all three sides, if I've got all three sides and an angle, then the cosine rule is the way to go. This is the cosine rule, or the law of cosines. So I take some triangle, it's triangle pig, and in triangle pig, we've got, this is maybe 15, and this is maybe 19, and this is maybe 61 degrees, and I want to know what that side length is. That is not the square root of -1. It is not. So what do I do in this scenario? Well, in this scenario, I squared is this side squared plus this side squared in either order, minus 2 times side times the cosine of the angle between them. So the first thing you want to show the person who's grading your paper is that you know how to crunch the numbers in this scenario, and your calculator will again be very helpful to you. That's 309.6585 and change. So then we take the square root of that, and we get 17.6 to three significant figures. You would report that to whatever was appropriate accuracy where you are taking trigonometry. I have a habit of reporting things to three significant figures. Is that reasonable? Sure it is. 61 is probably the medium angle in the triangle. It's probably the one that isn't the biggest or the smallest. And so 17.6 isn't the largest side, and it isn't the smallest side. Only one other thing to consider, and that is area of a triangle. If I want to find the area of this triangle, right here, this one, right here, area of this triangle right here, I can do that because the area of a triangle is 1/2 times one side times another side times the sine of the angle between them. One side, the other side, sine of the angle between them. So in this case, that's 1/2 times the side times the side times the sine of the angle between them. And again, your calculator is ridiculously helpful to you, so you just type everything right into your machine, and that's approximately 125. Okay, those are all things that should have been shown to you in some course involving trigonometry in high school. So what should you know how to do? Well, you should know how to use the sine rule. Let's see. If the measure of angle B is 50 and the measure of angle C is 40, and the side opposite angle C is 5. I think you should know how to find the side opposite angle B and the area of triangle ABC. And then, again, in a triangle ABC, if the measure of angle B is 20 degrees and A is 10 and B is 5, I think you should find the measure of angle A and the area of the triangle. But I don't just want you to find measures involving the sine rule. I want you to find measures involving the cosine rule. And so you should know, here's a triangle ABC. Let's pretend that angle B is 72 degrees and A is 16 and C is 10. I want to know what B is. I want to know what B is. And then in triangle ABC, if A is 11 and B is 16 and C is 18, I want to know what the measure of angle A is. Those are things that you should know how to do based on your preparation from high school trigonometry. I am looking forward to seeing your good work.